Hello. So we are going to go over the How is Energy Used in Organisms worksheet. So you guys should have tried to work through each of these pages before you watch this video, since I am going to kind of talk through it and go over some answers for some different things. So if we read at the top of the page, it says, in living organisms, energy is transferred from organic molecules like carbohydrates, fats, and proteins. Do the organisms use all of the potential energy that they consume? So what that's asking is, every single morsel of food that you eat, does that actually get turned into just rote energy for your body? So if we look at our first model, we have an organism. So we have organism A, and it says that grass ingested per day is 58 kilograms. So if we keep in mind that 1 kilogram is 2.2 pounds, that is a ton of grass. That is well over 100 pounds of grass. And then up on top, it says the amount needed to maintain biomass per day is 9.5 kilograms. Biomass, if we break down that word, that root word bio means life, and mass is the amount of stuff inside of a thing. So biomass literally means living stuff. So the amount of energy needed to maintain your biomass, that is energy that goes towards maintaining your protein, making muscles, making bones, growing. All of that stuff is maintaining your biomass. That's your living stuff. That's your living space. And then the second part here says egested waste. So egest, that basically is poop. So that is the amount that is just pooped right out. Okay. If we look at organism B, we have a little bit of different numbers. So we have food ingested per day is 6.2 kilograms. So still a lot of food. That's, probably almost 15 pounds of food, but a lot less than our organism A. The amount that is used to maintain biomass is 1 kilogram, and the egest per day per this organism is 1.6 kilograms. So what this is asking us to do is fill this out. So for our organism B, of course, we can fill these all out from the chart up here. We have it figured out for organism A, and the part that's missing is 24.7 kilograms. So that is not accounted for. So when grass goes in, 58 kilograms minus 9.5 minus 23.8, the amount missing is 24.7. So if we go do this for organism B, the amount ingested is 6.2 kilograms. Amount needed to maintain biomass is 1 kilogram, and the egest is 1.6 kilograms. So if we do the math on that part, we get 3.6 kilograms is not accounted for or missing. So what is meant by egested waste? That is poop. Okay. So your calculations to support what's missing. So basically that's just putting all of these numbers in and doing the math problem. So for example, if we do 58 minus 9.5 plus 23.8, and that equals 24.7, and you can extrapolate that out for organism B. So for number 4, what else do organisms do with the food they ingest besides maintaining biomass and waste production? So what else do you do with your food? You use it for energy. So do we think organism A is a carnivore or an herbivore? So remember, carnivore means meat eater, herbivore is a plant eater. Well, if we look up here, it says grass ingested. I've never met a carnivore that eats just grass, so I'm going to guess herbivore. And by the process of elimination, I am going to say that organism B is a carnivore. I can also deduce that organism A is a carnivore and organism A is an herbivore and B is a carnivore because of the amounts of food. So if you think about like lettuce, so if this organism would be eating all of this grass, heads of lettuce, green stuff, a whole head of lettuce is like 10 calories or something like that. So you need to eat a ton of it in order to get any nutrition. However, if we have a nice cut of meat or a nice steak, do you like my bad drawing skills? It's a lot more dense. If I wanted just 10 calories of meat, it would be like one little chunk off of a steak. It wouldn't be that much of food to be the same calories as a head of lettuce. So now you can move on to the second page, looking at Model B, and try to figure that page out. All right, so for this page, we have some different stuff. So instead of kilograms, we now have kcals. So if we remember from our life as a hunter lab, kcals is the amount of calories. So now we know that we in fact have an elephant and a lion, and the amount of grass that the elephant is eating per day is equal to 48,384 calories. Oh my gosh, so many calories. And they are losing per day about 11,000 calories to respiration. So that is through breathing and energy. So when we say respiration, we're not just talking about breathing, we're also talking about making energy. So that's walking around, finding food, all of that different stuff is respiration. And they actually lose a bunch of calories to heat loss. So your body has to spend calories in order to keep your body nice and cool at a nice temperature. So we lose a lot of those calories as heat. And then in our adjusted waste, they just poop out almost 20,000 calories a day. If we look over here at the lion, the numbers are scaled down for the food that a lion consumes. So per day, this lion might be eating 2,500 calories. Respiration, they're going to lose about 800 calories to moving around. Heat loss per day, about 700 calories. And then they are going to poop out about 600 calories of food. So looking at this one, what are 3 ways in which energy is used by organisms? Well, we use energy as respiration. We use energy for heat loss. And we use some of that energy as egest. Okay. So now what you guys can do is fill this chart out so you can grab those numbers from the table up above. And does the amount of energy from the food eaten in calories equal the amount of energy used? So you guys can figure that out. You should be able to figure that one out on your own and support that with your calculations from above. So now I want you to go on and try the next page. So pause the video and then we will go over the answers. So now we are actually going to calculate the efficiency of each of these diets. So the efficiency of an herbivore diet versus the efficiency of a carnivore diet. So which one of these diets is going to be the best bang for your buck? Where are you going to be the most efficient? So by that, how can I get the most calories that I can actually use and not eat just a ton? So when we are eating, heat loss and adjusted waste, that's all of our waste. And what we are going to do is do this little calculation here to figure out the efficiency of our diet. All right, so pardon my very sloppy drawing, but the way that we're going to plug this in is we have our heat loss, so 14,031 plus 19,837. That is our adjusted waste. I'm going to add those together and then divide that by the total calories of food ingested and then multiply that number by 100, and I should get around 70. Okay, so that would be about 70%. So that means that my diet here is 70% inefficient. So I'm really only using about 30% of the calories to maintain my biomass and actually like do stuff. So you can figure that out for the lion and then answer the question down below. So the elephant and the lion do not have the same amount of efficiency. Which organism is more efficient? And try to give a reason. So try to figure that out. And down below, you can try to figure out what percentage of the elephant's grass energy is available for the lion. So when the elephant eats the grass, a certain amount of that elephant that is basically made of grass is now available for the lion to eat. So you can figure out what that percentage is as well. So I hope this helps a little bit with kind of going through this worksheet. And if you have any questions, please let me know.